Okay, this time we've got to get this exponent alone, and notice that 2 right there is not being raised to the x power, so we've got to get rid of it. Now, if you think about this, that's 2 times 3 to the x. Can't be distributed. The exponent would come first, but we can get rid of it by dividing it out. So now it's 3 to the x equals 2. So now we can convert, write the word log, find the base, put it underneath, switch sides, and we have that x is approximately 0.63. Right, looking at this one, something doesn't belong. This plus 3 has nothing to do with the exponent, so we're going to get rid of it. Get 4 to the 5x equals 16. Okay, turning it into a log. The 5 doesn't belong, but it's up in the power, and we can't touch anything up in the power until it comes out of the power, meaning we need to switch it to logs. So write the word log, find the base, switch the pieces. Okay, then we have to get rid of that 5. That's when we'll divide by it. Now it's the whole log divided by 5. If you'd rather go boop, 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 calculator with this first and then divide by 5, that works as well. So x equals log base 4 of 16 over 2, over 5, which is, this time it's exactly 0.4. Next, let's see, we've got e in it, so I know there's an ln, but I've got to get rid of this guy. He has nothing to do with the exponent. So e to the x minus 6 equals 4. Okay, easy ones. E becomes ln. These guys swap places. 4 goes inside the ln. X minus 6 comes out. Okay, ln of 4, we could boop, boop, boop that right now if you wanted to. Or you can add the 6 to both sides first. Now be very careful with this because this says x equals the ln of 4 plus 6. It's not the ln of 4 plus 6. This right here is something that has to be popped into the calculator. So if you look on your calculator, third button up on the left, hit ln, type in 4, parentheses, plus 6, same thing on Desmos. If you type ln, it knows what you're talking about. And I get 2 decimal places would be about 7.39. Now, solving these equations comes in useful when it comes to exponential formulas. For example, a sum of $5,000 is invested at an interest rate, so we've got $5,000 invested, interest rate of 5%. Find the time required. That's T. Before we were given T, and we had to find the final amount. Now it says find the time required for the money to double. If the interest rate is compounded, oh, woo, woo, I know that word, compounded. That means we have to use our formulas. If it's compounded semi-annually, it is this formula. If it is compounded continuously, it's per. I don't know what's up, all these little bits and pieces. Okay, so what we have is, we do have an R. Oops. Oopsie. Oopsie. We do have R is 5%. Automatically change that to a decimal, 0.05. We also have P. P is going to be 5,000. We have to find T. We know it's semi-annually, so N is going to be 2. And we've got one more piece of information that it's going to double. Well, that has to do with A. That's our final amount. So if P starts out at 5,000, our A after so much time should be 10,000. Okay, plug in what we know. Got 10,000 equals 5,000 times 1 plus 0.05 over 2 to the 2t. Got to just solve from now. So I'm going to start by dividing that 5,000 out. He doesn't belong. So I've got 2 equals 1 plus 0.05 over 2 to the 2t. Now I'm going to simplify that stuff in between. I'm going to say, 0.05 divided by 2 plus 1, that's 1.025 to the 2t. Now, it's just a simple conversion from here. I'm going to take and write the word log. Actually, let me flip this. I like my variables on the left, and I feel more comfortable with logs when the base to the power is on the left side and the number that's out is on the right side. All right, so here we go. Write the word log. Find the base, write it under the log. Okay, swap sides. And then to finish solving, we would simply divide by 2. These 2's do not cancel because one is inside a log and one is outside a log. All right, so t equals about, looks like about 14.035, let's just say 14 years, about. Okay, now let's look at if it's compounded continuously. Again, we've got some of the pieces of information. We've got our P, and we've got our R, but we don't know our T. And we also know the A. So same idea, we're going to plug everything in. E is just the letter E to the 0.05 T. Solve just like normal. Get rid of the 5,000. 2 equals E to the 0.05 T. I prefer to switch it. I don't like the base to the power on the right side. Doesn't matter. You'll get the same answers. I just prefer my variables always on the left. Okay, I'm switching now. E automatically goes to ln, and these guys swap places. Okay, then we've got to divide by that 0.05. And we get that t is equal to ln of 2. Whoops, I just went and gave you a curvy wonky ln. I usually write it that way, but I'll be consistent. Which is about 13.86. So pretty close to 14 years. So in either case, it's going to take 14 years to double that money.